Solved problems. First problem. Show that exist xa or exist xb is a logical consequence of exists x left parenthesis a or b right parenthesis. So we have to show that any assignment in any structure which satisfies exists x left parenthesis a or b right parenthesis also satisfies exist xa or exist xb. Suppose M is a structure and S in an assignment that satisfies exists x left parenthesis a or b right parenthesis in M. There is an A in M such that S a slash x satisfies a or b in M. Thus, S a slash x satisfies a or b in M. If S a slash x satisfies a in M, then S satisfies exists xa, and hence the disjunction exists xa or exists xb in M. On the other hand, if S a slash x satisfies b in M, then S satisfies exists xb, and hence again the disjunction exists a or exists xb in M. Second problem. Show that for all x left parenthesis a and b right parenthesis is a logical consequence of for all xa and for all xb. Suppose M is a structure and S in an assignment such that S satisfies the conjunction for all xa and for all xb in M. To prove that S satisfies for all x left parenthesis a and b right parenthesis in M, let A be an arbitrary element of M. Since S satisfies the conjunction for all xa and for all xb, S a slash x satisfies both a and b in M. We have shown that S satisfies for all x left parenthesis a and b right parenthesis in M. Third problem. Show that exists x left parenthesis p0x and p1x is not a logical consequence of exists x p0x and exists x p1x. Now we have to come up with a model and an assignment. In principle, this could be a haunting challenge. Fortunately, in this case, the model and the assignment are easy to find. It makes sense in general to first try some very simple models. Either they work or else they may indicate a direction where a better candidate could be found. Suppose M is a structure such that M, the universe of the structure, is the set of two elements 0 and 1. P0 in M is the singleton 0 and P1 in M is the singleton 1. Let S be any assignment. Then S satisfies there exists x p0x and there exists x p1x in M. In the first conjunct we take the value of x to be 0, and in the second conjunct we take the value of x to be 1. However, S does not satisfy there exists x left parenthesis p0x and p1x right parenthesis in M, because there are only two elements in the model 0 and 1, and we can simply try both, and neither 0 nor 1 satisfies both conjuncts. Next problem. Show that for all x p0x or for all x p1x is not a logical consequence of for all x p0x or p1x. Solution. Suppose M is a structure such that the universe of M again consists of the two elements 0 and 1. P0 in M is singleton 0 and P1 in M is singleton 1. Let S be any assignment. Then S satisfies for all x P0x or P1x in M, because whatever value we take for x, it's either 0 or 1, so it either satisfies P0 or it satisfies P1. However, S does not satisfy for all x P0x or for all x P1x in M, because whichever disjunct we take, there is one element in the model which doesn't satisfy the atomic formula. Next problem. Show that if propositional symbols of a tautology are replaced by first-order formulas, a valid formula results. Solution. This is a somewhat long proof by induction on the structure of the propositional formulas. We start by formulating the problem properly. If A is a propositional formula, let A prime be the result of replacing each proposition symbol Pi systematically by a first-order formula Bi. So P0 or P1 prime equals B0 or B1. Then, for example, P2 conjunction not P1 primed would equal B2 and not B1. A final example, P0 implies left parenthesis P1 implies P2 right parenthesis primed would equal B0 implies left parenthesis B1 implies B2 right parenthesis. Suppose M is a structure and S an assignment. Let V be a valuation such that VPI is 1 or 0 according to whether BI is satisfied by S in M or not. Now we can formulate the given task in an exact way. The claim is VA equals 1 if and only if A prime is satisfied by S in M. Note that when the claim has been proved, it follows that if A is a tautology, then A prime is valid. We use induction on the structure or equivalently on the number of symbols of A. Case 1. A is just Pi. The claim is true by the choice of V. That is, VA equals 1 or VPI equals 1 if and only if A prime, which in this case is BI, is satisfied by S in M. But this is exactly the way we have defined V. Case 2. A is not a proposition symbol. We make an induction hypothesis. The claim holds for all subformulas of A or equivalently for all formulas shorter than A. Case 2.1. A is a disjunction B or C, and now as an induction hypothesis we assume that the claim holds for B and C. In this case, A prime is B prime or C prime. Now we can infer as follows. VA prime is 1 by the truth definition of disjunction if and only if VB prime is 1 or VC prime is 1. By induction hypothesis, this is equivalent to S satisfying B prime or C prime, and this is equivalent to S satisfying A prime as we wanted. Case 2.2. A is conjunction B and C, and as induction hypothesis we assume that B and C satisfy the claim. In this case, A prime is B prime and C prime. Now we can infer as follows. VA prime equals 1 if and only if VB prime equals 1 and VC prime equals 1. By induction hypothesis, this is equivalent to saying S satisfies B prime and C prime in M. But this is equivalent to S satisfying A prime in M. Case 2.3, A is negation, not B. And as an induction hypothesis, we assume that B satisfies a claim. In this case, E prime is not B prime. And VA prime is 1 if and only if VB prime is 0. By induction hypothesis, this is equivalent to S not satisfying B prime. And this is equivalent to S satisfying A prime. Case 2.4. A is implication, B implies C. Then E prime is B prime implies C prime. Now VA prime is 1 if and only if VB prime is 0 or VC prime is 1. By induction hypothesis, this is equivalent to S not satisfying B prime or satisfying C prime. And this is equivalent to S satisfying A prime. Case 2.5. A is the equivalence, B equivalent to C. Then A prime is B prime equivalence C prime. Now A prime is 1 if and only if VB prime equals VC prime. By induction hypothesis, this is equivalent to S satisfying B prime if and only if it satisfies C prime. This is equivalent to S satisfying A prime.